Good day. In this video, we're going to cover question 10 on cubic graphs from the Prelim 2018 of Gauteng. The question was worth 19 marks. It started off by saying the gradient of a tangent to the curve of f of x with this formula given at the point C, 1 and 7 is 17. Calculate the values of a and b. Then they say if it is given that a is 3 and b is 4, determine the coordinates of one other point on the curve where the gradient of the curve is also equal to 17. Then they say sketch this graph indicating all intercepts with the axis as well as the turning points. And then they say calculate the value of x for which this graph is concave up. A very good question to check your knowledge of cubic graphs. So firstly, they say the gradient of a tangent to the curve of f of x at the point C1 and 7 is 17. Calculate the values of a and b. We will use simultaneous equations. Firstly, we will take the original formula, substitute the 1 and 7 into f of x. 7 in the place of y, 1 in the place of x. Why? Because it lies on the curve. Then we simplify it and get this answer. We call it 1. Then we work out the first derivative of this formula, because the first derivative is the formula for the gradient, and that is equal to 17 at 1 for x. We put 1 in the place of x everywhere and equate it to 17 because the gradient is 17 at that x. Simplify it, then we have our second part of our simultaneous equation. From here, different people use different techniques on simultaneous equations. We just have to solve for a and b and we're finished. One possible way is to go to equation 1, get the b alone, substitute this into the place of b into the second equation, and solve for a. Then we substitute this a back into 1 or 2 to get the value of b. So b equals to 4. Please stop the video and get your brain around these calculations. Second part of the question, if it is given that a is 3 and b is 4, like we worked out, determine the coordinates of one other point on the curve where the gradient of the curve is also equal to 17. One way to answer it is to take the equation that we just worked out, work out the first derivative, because that is the formula for the gradient anywhere on that curve. Equate it to 17, because they told us that we want to find out where else the gradient is 17 on that curve. Put it in standard form. Then solve for x by either using the quadratic formula or factorizing. Then we get these two x values. The x equals to 1 we already used in question 1. So this is the second x value where the gradient will be 17. Plug this x value minus 17 over 9 back into the original equation to get his y friend. That will give you the y value. And then you have the x and the y value. You can write it in a decimal, round it off to 2 places, or as a common fraction. Remember, they asked it as a coordinate, so we write it in coordinate form. Please stop the video. Thirdly, they asked, sketch this graph, indicating all the intercepts with the axis as well as the turning points. I immediately opened up the sketch for you. Then we just see how we sketch a cubic graph. Firstly, we got a plus in front of that 3 there. That means the shape should look like this. Then we can work out the x-intercept by making y equal to 0. So we make y 0 and solve for x. So x is equal to 0, or x equals to minus 4 over 3 or minus 1 1/3. Then we work out the y-intercept by making x naught. You work that out, you'll see where x is naught, y is also going to be naught. So my x-intercept gave me a naught, and my y-intercept gives me a naught, so that then I know there my graph will go through the origin. Then you work out the coordinates of the turning points. You work out your first derivative and equate it to 0. And then solve for x. So that is the x values of my turning points, and I substitute them back into the mother equation, both of them. We already had this x naught and naught, so we just take this x value, plug it into the mother equation, and get the y value for that x value. So you can write it as a fraction or as a decimal rounded off to 2 places. So my 2 turning points are north and north, which we can see there, and this coordinate, which we can see there. And we have our x-intercept. Remember, this question was worth 4 marks. You'll get 1 mark for the shape, 1 for the x-intercepts, 1 for the y-intercept, and 1 for the turning points. Please stop the video and get your head around this sketching of a cubic graph. Next part of the question, and the last part, said calculate the values or values of x for which f of x, this same function, is concave up. There is more than one way to find the answer. I like to do it with a graph, and it's that blue part of the graph where the graph is concave up from the point of inflection towards the right. Firstly, we take our original equation, work out the first derivative, that's the gradient. Second derivative gives us the point of inflection. Then you equate that to 0 to find your point of inflection, and that is x is minus 4 over 9. And right of that number. So the answer is x is an element of, not including, minus 4 over 9 to infinity is where this curve will be concave up. Stop the video and get your brain around this technique. The second technique is to work out your second derivative. Your second derivative is positive where the graph is concave up. So you take the second derivative and make it bigger than 0. Then you solve for x, and then you have your final answer. This curve is concave up where x is bigger than minus 8 over 18. Or you can simplify it like this. So you can use any method you want. The final answer is x is bigger than minus 4 over 9. Please stop the video and get your brain around this. Please indicate whether you liked or disliked the video and subscribe to the channel. If you run into problems with sketching cubic graphs, you may send a clear WhatsApp photo of your problem to this number and a clear WhatsApp photo of where you tried to solve it. Then we will try and solve the problem for you and send back an answer as soon as possible. Enjoy cubic graphs.